Today we will see the remaining examples from exercise 3.1 based on elementary integral formulae. The first example from that is integral of x upon x plus 2. So how to integrate it with respect to x? So denominator contains x plus 2 and numerator is contains only x. So what we will do, we will adjust this numerator. Okay, we adjust plus 2 and minus 2 in the numerator. Then we take this x plus 2 in one bracket and minus 2 in another bracket. Then we will divide this numerator by this x plus 2. Here you will get x plus 2 upon x plus 2, that is 1, and minus 2 upon x plus 2. So here is the integral of dx and here is the integral of 1 upon x plus 2. So you know that integral of 1 upon x is log of mod x. So integral of 1 upon ax plus b is also log of mod ax plus b, where a is 1, so we don't need to divide it by this 1. So what is the integral? It is x minus 2 log of modulus x plus 2 plus c. Now the next example is 4x plus 3 upon 2x plus 1. So I is equal to integral of 4x plus 3 upon 2x plus 1 dx. So this I can write this 4x plus 3 as 2 times 2x plus 1 plus 1. So I write this numerator using the denominator. I write this numerator using denominator. Now, how it is possible, how to write the numerator using the denominator, I will explain in the coming example. Okay, here I will not going to explain it, but just look at this example. Here is 4x and we want 2x. Okay, so here is 3 and we want only 1, so I can write this 3 as 2 plus 1, and then I will take 2 common from this 4x and 2. So 2 times 2x plus 1 plus 1. If we simplify this, you will get 4x plus 3. Now divide this numerator by this 2x plus 1. Then take the integral separate, integral of 2 plus integral of 1 upon 2x plus 1. So integral of 1 upon ax plus b, its integral is log of modulus of 2x plus 1 upon 2. So the integral is I is equal to 2x plus 1 upon 2 times log of modulus of 2x plus 1 plus c. The next example is evaluate 5x plus 2 upon 3x minus 4. So I is equal to 5x plus 3 upon 3x minus 4. Again, we have to adjust this denominator in the numerator. Here is the coefficient is 5 and we want 3. Okay, so first of all we will adjust this 3 only here. How? By multiply and divide by 3 only. So here I get 5 upon 3 into 3x. Okay, as I have multiplied by 3, so here also it becomes 6, but I don't want 6, I want minus 4. So that form again that I have to simplify. So this 5x plus 2 I have written 5 upon 3 times 3x minus 4 plus 26 upon 3. Then I will divide this numerator by 3x minus 4 separately. So integral of 5 upon 3 dx plus 26 upon 3 times integral of 1 upon 3x minus 4. Here is the integral is x and here is the integral of log of modulus of 3x minus 4 upon 3. Okay, so simplify, you get 5 upon 3x plus 26 upon 9 log of 3x minus 4 plus c. The next example, x minus 2 upon root x plus 2. Okay, so again this numerator, we have to modify this numerator by expressing it in the form of denominator. So denominator contains x plus 5 and here is x minus 2. So here we have to add and subtract 5. So you get x plus 5 minus 7. Then divide separately. Okay, this x plus 5 can be written as root of x plus 5 bracket square. So one root will cancel and one will remain. Now take this root to the numerator. So x plus 5 raised to 1 by 2. minus 7 times integral of x plus 5 raised to minus 1 by 2. So here we get the factor ax plus b bracket raised to n, and its integral is ax plus b bracket raised to n plus 1 upon n plus 1. So use that formula 2 times, you will get the answer. Then just simplify. Okay, so you get I is equal to 2 upon 3 times x plus 5 raised to 3 by 2 minus 14 into root x plus 5 plus c. Don't forget to write plus c after finding the integral, otherwise your 1 mark will be reduced from the marks obtained by you. So now the next example, 2x minus 7 upon root 4x minus 1. Again, we have to replace this 4x minus 1, or we have to write this 4x minus 1 minus 7 using 4x minus 1. Now I am expressing, now I am telling you how we are going to use, or how you are going to convert the numerator using the denominator. Just stay on. Okay, this n is the numerator. Now how to express numerator? Numerator is equal to a into denominator plus b. So a and b are two constants. मग काय करायचं? Numerator is equal to a into the denominator. Denominator is 4x minus 1. So keep it as it is, multiplied by a. So here is 4ax minus a plus b. Now minus a plus b is a constant. This 4a is a coefficient of x. So equating the coefficients on both the sides. So you get 4a is equal to 2 and a minus a plus b is equal to minus 7. So from this equation you get a is equal to 2, a is equal to 1 upon 2. So I will put that a is equal to 1 upon 2 in the second equation, so that I will obtain the value of b is minus 13 upon 2. So a, I know the value of a, I know the value of b. So both values I will put in this equation. So numerator, that is 2x minus 7, is equal to a 1 upon 2 times 4x minus 1 plus minus 13 by 2. This is the way, this is the trick to write the numerator using the denominator. So replace the numerator then. Now divide separately. Okay, so you come to this step, 4x minus 1 raised to 1 by 2 minus 13 times 4x minus 1 raised to minus 1 by 2. So it is in the form of ax plus b raised to n. Its integral is ax plus b raised to n plus 1 upon n plus 1 times a. Okay, so simplify it. You get 1 upon 14 times 4x minus 1 raised to 3 by 2 minus 13 by 4 times root 4x minus 1 plus c. Evaluate integral of sine 4x upon cos 2x dx. So let I is equal to integral of sine 4x upon cos 2x dx. Now this sine 4x, I can write it as sine 2 into 2x, so that I will use the formula sine 2 theta is a 2 sine theta cos theta. Okay, the cos is 2x, will cancel and we get 2 sine 2x. So integral of 2, integral 2 is constant, we can take outside, and integral of sine 2x is minus cos 2x upon 2, because it is in the form of sine of ax plus b. While finding the integral, we are dividing it by a, and while finding the derivative, we are multiplying it by a. So this 2 will cancel and we get minus cos 2x plus c. Now integral of root 1 plus sine 5x. Now here this sine 5x can be written as sine of 2 into 5x by 2. 2 into sine 5x by 2. So that I will use the formula sine 2 theta is a 2 sine theta by 2 into 2 sine theta into cos theta. So sine 5x, I will write it as 2 sine 5x by 2 into cos 5x by 2. Then I have to write this one as sine square 5x by 2 plus cos square 5x by 2. Okay, so here I will get a plus b bracket square, a is a square plus b square plus twice ab. So cos of the bracket square and this root will cancel to each other and we get a integral of cos 5x dx plus integral of sin 5x upon 2 dx. So derivative of cos is minus, but integral is plus. So sin 5x upon 2 divided by 5 by 2 minus, minus it because integral of sin is negative. So sine phi, one mistake is there. Here we go. The integral of sine is minus cos. So integral of sine phi x by 2 is minus cos phi x upon phi x by 2 upon phi upon 2. So cos sine ax, sine ax in its integral is minus cos ax upon a. Use that formula and just simplify. I is equal to 2 by 5 sine phi x by 2 minus 2 by 5 cos phi x by 2 plus c. You can take 2 by 5 common, no problem. Now, the next example is integral of cos square x. Now, we don't know the formula to find the integral of cos square x, integral of sine square x, but we do convert this cosine square x and cos square x using cos double angle formula of cos 2 theta. So, cos 2 theta is 1 minus 2 sine square theta. Cos 2 theta is equal to 1, 2 cos square theta minus 1. Okay. So 1 plus cos 2 theta is equal to 2 cos square theta. So cos square theta is equal to 1 plus cos 2 theta upon 2. Separately divide 1 upon 2. So or we can take 1 upon 2 common. Then integral of 1 plus integral of cos 2x. Integral of 1 is x. Integral of cos 2x is sin 2x upon 2. So x by 2 plus sin 2x upon 4 plus c, integral of the given function. Now the next is x upon root x minus root x plus 3. Okay, so here definitely we have to use the rationalization. So you will rationalize the denominator. So multiply divided by its conjugate. So numerator contains root x plus 3, and denominator will contain a minus b, a plus b. So a square minus b square. So x minus of minus x plus 3. So these two cancel to each other and we get minus 3. So we can take away this minus 3. So outside the integral. So you get minus 2 upon 3 times integral of x raised to half plus integral of x plus 3 raised to 1 by 2. Use the formula x raised to n or ax plus b raised to n. You will get the integrals. Then just simplify. You get minus 4 by 9 x raised to 3 by 2 plus x plus 3 raised to 3 by 2 plus c. This is the integral of this given function. Now the next example is based on the same type. Again we have to rationalize only. Rationalizing denominator. So a plus b, a minus b, a square minus b square. Here 7x will cancel to each other, and minus 2 plus 5 is 3. So we can take here this 3 will cancel to each other, and we get ax plus b raised to n. Its integral is ax plus b raised to n plus 1 upon n plus 1 into a. So 7x minus 2 raised to 3 by 2 upon 3 by 2 into a is 7, the coefficient of x. Use the formula and just simplify it. You get 2 by 21 into 7x minus 2 raised to 3 by 2 plus 7x minus 5 raised to 3 by 2, because 2 by 21 is common to both the terms. Now f dash of x, here the derivative is given. F dash of x is x minus 3 upon x cube, and the value of the function at 1 is 11 by 2. We have to find the original function. What will be the function? Okay, whose derivative is x minus x cube. Now we know that derivative and integration are the opposite processes. So f of x is nothing but integration of f dash of x dx. You must know. Okay, derivative and integration. Integration also known as an antiderivative. Okay, or primitive. So the f of x is equal to integral of x minus 3 upon x cube. Now how to find the integral of x? Integral of x 1 upon x cube, that is x raised to minus 3. Integral of x is x square upon 2, and integral of x raised to minus 3 is x raised to minus 3 plus 1 upon minus 3 plus 1. So f of x is x square upon 2 plus 3 upon 2 x square plus c. This is our f of x, but here is plus c, constant of integration. This is our equation number 1. Now one more condition is given, that f of 1 is equal to 11 upon 2. So use that condition to we find the value of this c. Put 1 in this equation. 1 square upon 2 plus 3 upon 2 times 1 square plus c plus is equal to 11 upon 2. So 1 upon 2 plus 3 upon 2 is plus c is equal to 11 upon 2. So 3 plus 1 is 4. So c is equal to 11 by 2 minus 4 by 2. So in next step, 11 minus 4 upon 2 is 7 upon 2. So the value of c is 7 upon 2. So put that value in equation number 1. You get the function f of x is equal to x square upon 2 plus 3 upon 2x square plus 7 upon 2. This is the required function whose derivative is x minus 3 by x cube. Okay. So this is all about the exercise 3.1. In next lecture, we will start the methods of evaluating the integrals. Okay, so we will stop here.